video, we're going to go over hypothesis testing, and specifically we're going to look at testing a population proportion, so a 1 proportion z-test. Recall for proportions that we have to verify that the distribution is normal, or at least approximately normal, so they can either tell us that it follows a normal distribution, or we check that condition n times p times 1 minus p is greater than or equal to 10. I also put the z-score for proportion, so we have our data minus mean over standard deviation, and that breaks up into our p hat minus p over the square root of p times 1 minus p over n. Here are the steps for hypothesis testing. So we'll determine the null and alternative hypotheses. We'll select a level of significance, or one will be given. We'll find the test statistic. In this case, we'll just be looking at a z-score because proportion is always a z-score. Determining the p-value, making a decision, and stating the conclusion. Okay, so let's look at an example. June believes that 50% of first-time brides in the United States are younger than their grooms. She performs a hypothesis test to determine if the percentage is different from 50%. June samples 100 first-time brides, and 53 reply that they are younger than their grooms. For the hypothesis test, she uses a 1% level of significance. Okay, so let's go through the steps. Step 1, determine the null and alternative hypotheses. So here's where we have to worry about notation. We want to know if we're testing a mean, which is an average, or a proportion. So in this case, because we have percentages, we have a 53 replying out of 100, this would be a proportion, so we'll be testing p. So here's what our null and alternative looks like. Our null is p equals 0.50, that comes from the 50%, and then the p not equal to 0.50 comes from her thinking that it's actually different from 50%. So different doesn't mean greater or less than, so we put the not equal to. Step 2, we'll select a level of significance, alpha. They gave it to us here, 1%, so we'll write that as a decimal. Moving on, I just rewrote the example here. We need to find the test statistic. So remember, here's our formula for a test statistic. That's our z-score. So we have the p, that's our 50%. We have our n, that's our 100. We just have to find this p hat, that's our missing value here. So if n is 100, that would make x 53. So let's write that down. And then to get p hat is x over n, so we put 53 divided by 100, which is 0.53. So now we can fill in all of this information. We get 0.53, there's our p hat, our 0.50, our p, and then we fill in p down in the denominator and our n. To calculate this, let's go to the calculator. We're going to need parentheses around the numerator, so 0.53 minus 0.50, and you can leave the 0 off if you want, divided by square root 0.5 times. Now, instead of putting in the 1 minus 0.5, I'll just do that in my head. So 1 minus 0.5 is still 0.5, so I'll put in the 0.5. You can put in the whole thing, the 1 minus, but I just think it's easier just to do that subtraction in our head. Divide by 100. We'll press equals, and we get 0.6. Okay, so let's write that down. So now we have our test statistic. We can move on to finding the p-value. So the p-value is going to be done in the calculator. So let's go ahead and find that test. So we go to Stat, Test, and it is a z, but a z-test will bring up means and sigmas and x-bars, and we don't really have that. So we want to make sure to go all the way down to a 1 prop z-test. So that's the z-test for proportions. Okay, so we have to fill in all of our information. So p was 0.50, x was 53, n was 100. Here we have a not equal to, because remember it said different. And then let's go ahead and calculate that. Okay, so we can see that we've got that same notation as our alternative hypothesis, our not equal to 0.5. We verified our z-score, so if we look over here, that was exactly the z-score that we got from computing it from the formula. And here it shows us that our p-value is 0.5485. So let's go ahead and write that down. And remember, because this is a not equal to, that's a two-tailed test, so we actually have this is a z-value of negative 0.6 and a z-value of 0.6. Sorry about the typo. The area in both of these tails combined is that p-value of 0.5485. Okay, so last little thing, we have to make a decision. So we're going to compare our p-value to alpha, and we always ask the same question. Is the p-value less than alpha? If so, we reject the null. So here we go. Is the p-value less than alpha? So we've got our p-value over here on our calculator, and our alpha was 0.01 from this 1% level of significance. This is not true, so no, we do not reject the null. That will help us make the conclusion here. So if we do not reject the null, that means that we do not have sufficient evidence to support the claim that the proportion of brides who are younger than their grooms is different from 0.5. Or you could also say percentage instead of proportion, and then use that 50%.